absolutely exploiting the advent of technologies in various shapes and forms and embedding them in a way so that they become a thing which can communicate one with the other. So the basic senses that we have is our vision, our auditory faculty, and then obviously the senses. But then humans are there in limited areas. But if we need to really look at automation, and obviously I'll come to that, why we need to have automation. We have heard some statistics in the morning that there are certain realities dawning on us, and we need to respond as business, as government, or as citizens of the world. But here is the concept is that human ability to reach up to the nooks and corners of the value chain of a business is limited. So can we replace? Now, I'm sure we have seen enough around us, like camera, which is nothing but an extended eye for us. And then all network that we talk about is nothing but the nervous system. And then we leave the brain into a software, into a human brain in true sense, or something that we've heard of, articulating or simulating a human brain response within a quasi-system. So, I'm not going to delve into the use cases. Internet of Things are all around us. I don't know how much you can read here. I'm not sure. So it tells us almost every industry, every segment where we see some use of Internet of Things. So basically what it means is that we embed something like a sensor or some device, maybe a biochip, or a very simpler form of transducer-based capabilities, and we try to gather data of that situation, that context, and this data could be anything, right from a visual response, it could be temperature, pressure, it could be acceleration, it could be angle of a particular equipment, so on and so forth, so that we take better decisions, or probably we take automated decisions right at the context, right at the edge of the network. So that's what basically what we try to do is, what I said is, what it is basically is an extension of human senses. The method is obviously deeper insight and automation. The outcome is something that what we need to focus on is quality of service. Now, quality of service is again very subjective. It depends on what service you are into. Are you the consumer or are you the producer of service? And how do you enhance the quality? Now, quality, we all know, is not about the best of the things, but rather conformance to the requirement. Now, efficiency is also another thing. Cost absolutely is something that can be addressed using Internet of Things kind of capabilities, and risk mitigation. I don't know how much I can relate. I'm limited by the stuff that I have with me, but I would try and touch upon some of the use cases or scenarios where IoT has helped and has been helping us and is going to help us in future, whether you are at this end of the spectrum as a consumer or the other end of the spectrum as producer. So in short, there are four things that in IoT we will focus on. First of all, things. Now, what is things? Things are basically the living or non-living forms having a sensor or a device embedded into it or just carrying with it. What it does is it emits and collects data, and that data gives us a lot of insight, which could be mundane knowledge about the business or something that is not so apparent. And finally, we are looking at quality of services. Now, quality of services involves everything, whether you can reduce cost of your operation, whether we can enhance the quality of your product, and whether you can mitigate risks of citizens or residents, and so on and so forth. Now, so what we need is a device. So I'm not going to discuss about the device part of it. I would rather talk about how the data would be managed and stored, and how analytics or analysis will be done on those data. And finally, how adaptive intelligence. So that's another word of or a substitute for whatever we've heard so far, AI, machine learning, RPA, whatever we call it. These are nothing but adaptive intelligence. The intelligence had been or would be adapted by the and I would say the placeholder of this information. So there are a lot of things that happens at the back end or the backdrop, which I'm not going to elaborate, but I was told to highlight the role of software in this field of IoT, because IoT is in one sense, it is being perceived as a device, a sensor, but then there are a lot of things that we need to make it happen so that the devices can talk to each other. The ultimate game is to make these devices talk to each other, and that is the end result of an IoT. Now, what are those backdrop mechanisms? I'm just going to touch up. It's not a session to give you details of what it is and how that can be done, but just to reflect. So basically, capture of those information from the sensors is one of the critical part. It is challenging, but if we can do few things in a better way, what we call virtualizing of the capture mechanism, and can address any type of devices through any type of network and capture it fast. Now, I tell you why it is important to capture fast, because every event that happens has got a life cycle or a lifespan. And for the business or for the operation to derive the value of that event, the ecosystem has to respond in that duration. Now, there are nanosecond activities, and there are activities or developments that happen over the years. So example, nanoseconds like in terms of, let's say, a critical operation of a nuclear reactor or an aircraft movement. So there are nanosecond developments that are happening for which you need to respond. And then there is also development that occurs over a period of time, years, like glacier movement or any other geological event that happens. But these are also events. Now we need to categorize what event matters to us in what way and capture that business value within that timestamp. So that's how we look at how do we connect and persist all these informations, and that brings us all these concepts of big data, fast data. So this is the whole spectrum is all about how do we react and respond conformant to the requirement of the situation. And then we analyze, for which we need to think of few things in terms of performance, deep discovery. And finally, we need to integrate with other ecosystems. So IoT is an extension of the IT environment that we see in our doorsteps or in the backyard, wherever it is. Whether you are a big enterprise, whether you are a government department, whether you are a software developer, or whether you are a value-added service provider, everywhere it is all about integrating those extension of technology into the mainstream IT. Till the time the mainstream IT is being replaced by what we hear about robotics and other fantastic things that are going to happen in life. So I'll skip these details, the solution spectrum. I was not very clear what kind of audience we would have today. So I will just briefly make a change in the style, and if we can bring up a video, just to, sorry. Just for a change, if we can have a look at a video, a short video, which will tell us how Industry 4.0 is being impacted by IoT. It's not needed. So what I'm going to share here is it's self-evident. It's okay. Oh, okay. Not a problem. Not a problem. Not. No, not this one. Okay. Duplicate. So this video shows basically yeah, so this is basically a shop floor where we are seeing the things are being manufactured. Now, with IoT, what we see is that It's again also automation, some robotics are there. Uh, Data are being transmitted all along from various sensors embedded into these various arms of robotics, and these are helping us to build a finished product, and each of these processes are being captured at the right in context. As we talked about the business value of lifespan of an event is something, and so here what we are saying is that we are capturing all the parameters in the whole life cycle of this production, and it doesn't matter where those factories are. Now today we are having an integrated way of manufacture. So here we see plenty of parameters which are being captured through all these sensors that are coming out on our way. And this is being reflected on some device being held by some decision makers on the shop floor or wherever they are, whosoever is responsible for the overall outcome of the manufacturing process. So here we can see that in more details, the various levels of equipments and stages of development and manufacturing and various parameters. And that's what we're trying to do is to replace a human intervention through devices. So it's not possible to keep human intervention in terms of reading those parameters or visually checking some quality part of it. Rather, it's being replaced by those sensors. So this is where we can focus on some part of parameter which may help us to understand what is going wrong, and this will tell us in terms of the exact parameter whether it's some temperature, some quality part, and it also looks at the outliers and finds out and detects and puts an alert to the right people. So this is also something called analytics part of this whole process. And so this Industry 4.0 is basically being impacted where we see that products, machines, and personals are interacting amongst each other. So if I come back to my session, I would probably talk about a couple of other things. Rather, I'll skip one, and I'll talk about something that happened in not so recent past. So this is something that happened, I think, a decade ago when there was a disaster during tsunami in this South Pacific, or rather with Southeast Asia. And our government and some arm of the government wanted to set up something called early warning system. And we were interacting with a few wings, oceanography, and a few other wings which deal with data. So we didn't know that this is going to be called an IoT after a decade, but the buoy, they deploy those buoys on the sea floor and at the seabed. And they detect all the velocities of the waves and detect some anomalies. We have been hearing about anomalies. So this is all about based on anomaly detection, whether it's a natural wave velocity or there is some disruption. So basically to detect epicenters, and based on the scientific data model they have, can they provide some advisories in 2 heartbeats. 2 heartbeats means basically first heartbeat is basically to make aware of an event that has happened. So even now, if we hear any earthquake that happens, we get an advisory within a minute that there is an event in that epicenter, and we will come back with an advisory. And somebody says, okay, some other authority would come back and talk about some inundation or tsunami or something, and at a later point in time, we hear that alert has been suspended for a while. So these are multiple, I would say, wave of decision making or advisories. So I'm not going to delve into details, but I'll just show you some of the screenshots where how this kind of machine learning or IoT-based data that can help building scientific models. So I'm just sharing some of the screenshots where we collaborated with multiple teams across Asia Pacific, and we helped some of the governments with some mechanism to complement the scientific model that they have. So they will detect the events, they will find out similarity of those events based on their historical events. So that's something called a brain. That brain has been built by the scientific data model of seismography. And then they will come and figure out the possible events that might happen. So basically what I'm trying to say is that it's just not about business, but it's also about lives of citizens that can be impacted using IoT. And that brings the final stage of my conversation here. So what we are saying is that whether you are one part of the spectrum of providers of these solutions or you are at the other end of the spectrum while consuming those capabilities and solutions, everybody has a role, everybody has an opportunity to build business. So for an application developer, as we know that there are latest capabilities that are coming up, whether you are doing it in mainstream technology or something that has been changing or something which will complement those robotics or artificial intelligence, you have a scope to build a kind of a differentiator. For the platform providers, obviously, there are a lot of R&D going on around building an IoT infrastructure which can scale up to the kind of expectations, because we are talking about some 40 to 50 billion devices that will be active by 2020 or 2022, and that will mean it's not just, I can't really comment on the volume of the data along the streams. In terms of value-added service providers also, they can add a lot more values on building fantastic solutions around IoT. When it comes to the other end, how do you adopt? Industries obviously are looking at almost every possibilities. And as we speak today, industry segments are also, the differentiations are getting blurred. Those who are in manufacturing are no more just true blue manufacturing organization. They are delving into some part of it in terms of some kind of telecommunication, some part is into some kind of retailing and so on and so forth. So these industry segments are getting blurred with all these advances that are happening. And most importantly, government or any public services, authorities or departments or projects that are coming up that can touch lives of everyone to make it simpler and mitigate risks. So with that, I will stop here and await your questions as and when it comes. Thank you.
Thank you, Roger. Thank you, Roger. Thanks all the speakers. Now we are inviting questions from the floor. I think, yes, please. Please tell your name and whom you want to target.
The question is for Roger Chakraborty. In your last slide of opportunities for everyone, you spoke of value-added service providers. What do you exactly mean by them?
If you are providing some solution services to your end customers, if you are into IT business and you provide services, then you can build those disruptive solutions on IoT and can create a differentiator for yourself and get business. That's it.
Just an example of what do you mean by disruptive? Just an example. That's a simple example.
I'll hand over to Mr. Raghupati.
The biggest opportunity for the startups is the API ecosystem. For example, we are building the GST platform for the Government of India. While yes, that's an opportunity for Infosys per se, but there are GSPs which are going to consume the APIs and allow ordinary taxpayers and citizens to file. So when he's talking about value-added services, obviously there's a core, which is the GST platform, which is a big gorilla. But then there's a value-added services like an API which is being produced. Similarly, there could be many APIs to banks, like Professor mentioned, which is, if you take a payment bank, A payment bank is only a pass-through of a payment. But then they could tie up with insurance companies and people could build APIs to that. So there will be various value-added services there.
Thank you, both of you.
I thought Mr. Subir Lahiri, he wanted to ask to Caesar, please.
Strategy, your demo didn't clear my idea or the understanding of the difference between a simple ERP system and your RFP really.
Yeah, so the ERP system remains as a ERP system. So in one case, you have a user using the ERP system. So what we showed there was a robot who was running the ERP system and no human being was using that. So you will have systems which either human being use or we replace that human being by a robot who does that same set of tasks.
It may not be essential all the time.
No, no, not at all.
Right.
Not at all. Absolutely.
Any other question? Yes, please.
I'm TD Mujumdar. You were saying something in that Watson, IBM's Watson is probably for legal advices and related to legalities. And the demonstration here was with purchase order. I didn't really get the connectivity of it.
Yeah, so
I might have not understood it, but then that's my...
Yeah, so Watson is a cloud-based service. It provides business functions like legal, health. It also provides you with artificial intelligence functions. So including things like creation of a taxonomy, natural language understanding, natural language generation. Now, what we have here is a solution which is called IBM Automation with Watson, which uses all those artificial intelligence feature of the Watson cloud platform. Okay, so yeah.
Next. Yes, please.
So the gentleman from, I think, Infosys said that there'd be 4 major disruptive forces in the field of medicine, okay, which would replace normal physician, a physician or a doctor. Now, what I would like to ask you, that if a person is sick, let us say he goes to, and it's happened many times, he says he gets all his tests done, but all his tests are clear. Now a good doctor, physician, he looks at a person and out of experience gets a feel of the disease and makes a diagnosis looking at the person. Now I wonder how would a computer replace that? He would at the best say that all these tests, the data from the test would be fed to a machine, and according to a certain logic, it would interpret it. But how would a computer sense what a doctor does out of experience looking at a patient? He gets a diagnosis done, and it's very, very correct also.
Yes, Raghupati.
How would you respond to that?
Yeah, so firstly, let me re-clarify what I said. I did not say they will replace a physician. I said that they would disrupt the world of medicine. A good physician who has tribal knowledge is not to be replaced. In fact, I was having this argument with my wife, who is a doctor. In Bangalore and Chennai, where I come from, we had old physicians who, when you walk in through the door, could diagnose simple things like this boy is having typhoid, etc. I was just sort of pulling her leg, saying that the generation coming now requires a CT scan, requires everything to diagnose. Let me also say remark on one thing. For the next 50 to 60 years at least, computers are not going to replace human intelligence. I said disruption. I did not say replace. So, sir, you are talking about the highest level of physician who possibly, I'm sure Calcutta has many of those and has produced many of them, who can diagnose. But at an average level, today a physician or a doctor depends upon a lot of reports. This artificial intelligence system will help you to put all the reports together. The first one on genetics. Now, I went and stood in AIMS just to see how the outpatient works. A patient who comes from Bihar just doesn't know he's an illiterate person. He just doesn't know what his genetics are or what is uska dada ka kya tha, uska pardada ka kya tha. So a genome sequencing, if it is done, gives the doctor a fair idea of what is the sort of genetic makeup he has, which you can't get in the 10 or 15 minutes you can spend with the patient. Right, sir? The second, electronic health record. The same study which I did with ICMR, and I participated in it out of personal interest, we found that people who migrate into Delhi are not able to tell the outpatient doctor at AIMS कि क्या दवाई लिया पता नहीं sir. Okay. So electronic health records helps that way. So the doctor gets at a glimpse the genetic disease, makeup of the patient, what he has taken, which otherwise the patient will not be able to say. Imaging, of course, it's just a question of all the images being available at one point. And wearables, we have at least a 50 to 60% shortage of beds in the country. So a patient, and I was traveling once from Mayer, I was traveling from Delhi to Mayer in Bhopal, from Bhopal. This patient had come all the way after having had a bypass, and he had to go back every month to AIMS. So imagine if we can put a wearable on him and the doctor can monitor him, it will reduce the capital asset in medicine. All these four forces are only going to aid. They are never going to replace a very good physician.
Thank you, sir. Thank you. I think in last questions, please, madam.
This is a general question more on AI than on IoT. I know this panel is on IoT, but I just thought if you could throw some light. The question is, it has been said that in the earlier generations of AI, it was all based on what learning human beings already had, and that was put into the systems, perhaps even in Watson and things like that. Whereas now the technology trend is emerging so that the machines are becoming, machine learning is coming up and they are becoming self-learning, and it is said that they will very soon have more knowledge and be able to diagnose better than humans. So can any of you throw some light on this area?
I'll take a 1 minute stab at it and then refer it to respected Professor Mazumdar, because I think he'll be the better person. There are two types of artificial learning, madam. One is the neat AI and one is the scruffy AI. I do not remember which, but I think the Stanford school started the neat AI, which